Hello everyone. So now we can solve another problem. The ground state of wave function for hydrogen is, so the ground state wave function is given. Calculate the probability of finding the electron at a distance less than a naught from the nucleus. The second one is between a naught by 2 and 2 a naught from the nucleus. So let us solve this problem. Now what is given? The given is the ground state wave function, that is psi of r, which is equal to 1 over square root of pi a naught cube e power minus r by a naught. So now let us calculate the probability. So what is the probability of finding the electron at a distance? Okay, probability of finding an electron, maybe the electron at a distance less than a naught, so which is written as 0 to a naught, and this is modulus of psi of r square into d tau, but d tau contains a radial part which is r square dr, and we have angular part. Since there is no angular part here, so we can integral angular part, so it will give you 4 pi. Okay, so this is 4 pi, and this is in 0 to a naught modulus of psi of r square into dr. Okay, now we can substitute the psi of r. Psi of r is given as 1 over square root of pi a naught cube, okay, a naught cube e power minus r by a naught. So modulus of psi of r square is equal to simply 1 over pi a naught cube e power minus 2r by a naught. So once if we substitute, you will get 4 pi. This normalization constant I will take outside, pi a naught cube 0 to a naught, and this becomes r square e power minus 2r by a naught into dr. So this pi gets cancelled, so we will get 4 by a naught cube. So this integral we have to solve, r square e power minus 2r by a naught into dr. So this integration we have to solve. Okay, let's now evaluate this integral. So this integral is, let me write down here, 0 to a naught r square e power minus 2r by a naught into dr, and this we can use integral by parts technique to solve this integral. So let u is equal to r square, so du is equal to 2r into dr. Now what about dv? The remaining part, that is e power minus 2r by a naught dr. By integrating this, v is equal to e power minus 2r by a naught by minus 2 by a naught, that is minus a naught by 2 e power minus 2r by a naught. So uv that is r square into this, so a naught by 2 r square e power minus 2r by a naught 0 to infinity minus v du, so v is minus and minus plus a naught by 2 du, and there is 2 here, 0 to a naught, this is r e power minus 2r by a naught into dr. 2 gets cancelled, so this is 0 to a naught, not infinity, right? So therefore this integral is minus a naught by 2, and upper limit when I substitute, it is simply a naught square e power minus 2, because when I substitute for r, there will be a naught, denominator also a naught, so it becomes 1. So e power minus 2. When I put r is equal to 0, the first this term vanishes, so you will get plus a naught, and this is 0 to a naught r e power minus 2r by a naught into dr. Okay, let us now evaluate this part alone. So this part alone will evaluate separately. Let u is equal to r, du is equal to dr. Now dv is the remaining term. So dv, the remaining term is dv. So we can write down the v by integrating this. You will get the same value, because this is a naught minus a naught by 2 e power minus 2 r by a naught. So when we expand this uv rule, so let me write down here only this part. uv is r, so minus a naught by 2 into r e power minus 2 r by a naught, 0 to a naught, minus integral v du. V is minus a naught by 2 times this, so a naught by 2, so 0 to a naught, and e power minus 2r by a naught into dr. So when we expand this, so we will get minus a naught by 2. When I substitute a naught, I will get a naught into a naught square e power minus 2, lower limit becomes 0, plus a naught by 2, integral of this is e power minus 2r by a naught by minus 2 by a naught, and this is 0 to a naught. Okay, so this becomes a naught square by 2 e power minus 2, and this becomes minus a sub 0 square by 4, and the upper limit when I substitute e power minus 2, lower limit when you substitute e power 0 is 1. So let us substitute this one here. So this is minus a naught cube by 2 e power minus 2, and this is the bracket term a naught times this a naught times this entire term. So let us multiply this. So minus into plus is minus, so minus a sub 0 cube by 2 e power minus 2, and minus a sub 0 3 divided by 4 e power minus 2, and minus into minus plus, so this is plus a sub 0 cube by 4. So this is this integral. Okay, so let us combine the common terms. So when we combine these common terms, so this is minus a naught cube by 3 minus a naught cube by 3 is simply minus a naught cube e power minus 2, and since it is minus 1 by 4, so it is simply minus 5 by 4 e power minus 2 plus a naught cube by 4 into a naught cube, right? So when I substitute this one here, when we substitute here for this bracket term, I'm just writing the probability. Okay, the next page, 4 by a sub 0 cube times this term minus 5 by 4 a sub 0 cube e power minus 2 plus, and this is a sub 0 3 divided by 4, and when we multiply inside and this part, the first term becomes minus 5 by 4 e power minus 2, 4 gets cancelled, right? So therefore minus 5 e power minus 2 plus 1. So this is what you will get. It is 1 minus 5 e power minus 2. Okay, from the nucleus. Okay, between a naught by 2 and 2 a naught from the nucleus, we will calculate the probability. So the second part, B part. Now what is the probability? So the probability now becomes, so this is the probability of finding the electron at a distance between a naught by 2 and 2 a naught from the nucleus is equal to, so this integration we have to solve. The integration which we have to solve is nothing but this integral, same integral, this part. Okay, so similar integral. So therefore we have to calculate this integral, the same one here, but the only difference from this problem is the limits of the integral. So let me write down the integral here. Okay, so the integral is 4 by a naught a sub 0 cube integral r square e power minus 2r by a naught dr. So the lower limit is a naught by 2, the upper limit is 2 a naught. So let us calculate this integral. So this becomes similar calculations. Okay, similar calculation like this. So first we have to integral by parts. So when we do integral by parts, this you will get. So let me write down the results here. So this results will get. So first one is minus a naught by 2 r square times this. So minus a naught by 2 r square e power minus 2 r by a naught. Now the limit is a naught by 2 to 2 a naught minus upper limit. So this part will become a naught. Okay, so a naught times plus a naught times, now this integral 0 to, so sorry, this integral my a naught by 2 to a naught by 2 to a naught. Okay, so this is r e power minus 2r by a naught into dr. So we have to solve this integral once again. So let us rewrite the answer from the previous problem. So when we evaluate this integral, this is the integral result. Okay, so we will substitute this also there, and we will substitute the limits, then you will get the answer. Okay, so this integral limit value is minus a naught by 2r times that exponential part. So this part I am just substituting bracket. Let us put this entire thing as a bracket, integral part. So minus a naught by 2r e power minus 2r by a naught. So a naught by 2 a naught. Okay, then this part plus a naught by 2, the integral result. Now what is the result of this integral? So the result of this integral, a naught by 2 times minus 2 by a naught, that is minus a naught square by 4 e power of this, right? So this is minus a naught square by 4 e power minus 2r by a naught. So these two limits, a naught by 2 to a naught. Okay, so when we substitute these limits, so we can substitute these limits 4 by a naught cube when you substitute the upper limit, so this becomes 2 square is 8, so 4 a naught square, so minus 2 a naught square, because there is a 2 here denominator, so that cancels, and e power minus 4 a naught by a naught, therefore e power minus 4. And when we substitute the lower limit, so this becomes minus and minus plus a naught cube, 2 square is 4, 2 8, so e power minus a naught by a naught, therefore e power minus 1. So this is the value after we substitute the upper and lower limit. Then there is a naught here, so we have to multiply a naught in these two terms. So let us substitute the upper limit and lower limit. So when we substitute the upper limit, simply it is once again a naught, therefore 1 2 gets cancelled. Okay, so a naught square, therefore a naught cube, so you will get minus a naught cube, okay, and e power minus 4, e power minus 4, and this part lower limit, when we substitute a naught by 2, therefore this becomes minus and minus plus a naught cube by 4 e power minus, and a naught gets cancelled, 2 gets cancelled, e power minus 1. Okay, and last term there is a minus sign here, so a naught cube by 4. Okay, now upper limit, when we substitute, this becomes a naught e power minus 4, and minus into minus plus a naught cube by 4 e power minus 1. So let us simplify this. So there are two terms, coefficient of e power minus 4, so we can group it separately. Coefficient of e power minus 1, we can group it separately. So let us now start with e power minus 4. So what we will get is, so this is a naught cube, so therefore this is minus 2 a naught cube, okay, and that is minus a naught cube, so minus 3 a naught cube, and that is minus 1 by 4 a naught cube. So you will get e power minus 4, and e power minus 1 terms, when we combine, so you will get this 1 by 4, 1 by 4, 1 by 8, and therefore this is simply when I take 8 as an LCM, therefore 1 by 8 plus 1 by 4 plus 1 by 4, this is simply 8 as an LCM, 1 plus 2 plus 2, therefore 5 by 8, so therefore it is plus 5 by 8 e power a naught cube e power minus 1. So once again we can take simplify this. This is 4 by a naught cube, and this is minus 13 by 4 minus 13 by 4 a naught cube e power minus 4, and this is plus 5 by 8, okay, e power a naught cube e power minus 1. We can multiply these factors inside, and we'll write down the first positive term, 5 by 2 e power minus 1 minus 13 e power minus 4. So e power minus 1 is approximately equal to 0.3678 something like that, and e power minus 4 is approximately equal to that is 0.0183, something like 156, something like that. Okay, so when we substitute these values, these are approximately equal to 0.682. Therefore the probability of finding the electron at a distance between a naught by 2 and 2a naught from the nucleus is 0.682. One more point we should notice, which is greater. We have calculated two results. Which one is greater? So I will write down the summary of this. The probability of finding the electron at a distance between a naught by 2 and 2a sub 0 from the nucleus is greater than the probability of finding the electron at a distance less than a naught from the nucleus. Because the first case the probability is, for this case, that is for distance less than a naught, the probability value is nearly 0.323, whereas in this case, the distance between a naught by 2 and 2a naught, the probability is 0.682. Therefore this one is greater than this. Thanks for